Hello, and welcome to the Zook Welded Rupture Disc webinar. Thank you everyone for attending today's webinar. My name is Cameron Holmes, and I'll be your host today. First, a bit about me. I'm the Vice President and General Manager of Zook's Metal Division, and have worked with many customers providing engineered rupture disc solutions for over 15 years here at Zook. For anyone that may not be familiar with Zook, we're a global market leader with over 90 years of manufacturing expertise of high quality metal and graphite rupture discs, as well as other pressure relief products. Zook has global locations in the United States, United Kingdom, Canada, and Malaysia. Zook manufactures out of 2 state-of-the-art production facilities. Our graphite facility is in the USA, and our metal rupture disc facility is in Canada. For more information about us, please visit our website at zookdisc.com. In today's webinar, we will be discussing welded rupture disc assemblies. And by the end of the webinar, you will have a better understanding of what they are, when to use them, and how they can solve challenging customer applications requiring pressure relief or pressure activation management. Before I introduce our presenter today, a couple of housekeeping items. If anyone is experiencing any technical issues, please let us know by using the Q&A box, and our technical support staff will assist you. We will also have time at the end of the webinar to answer some questions. So again, please use the Q&A box and ask your question. If we don't get to answering all the questions, we will respond back to you after the webinar. And lastly, everyone will be receiving a recording of the webinar and a PDF of the webinar slides. I would like to now introduce our presenter today, Justin Murray. Justin's the Operations Manager at Zook's Metal Division. Justin headed up the Welded Division for over 5 years before changing roles at Zook. Justin has an enormous amount of experience in the pressure relief industry, and today he will be teaching us about welded rupture disc solutions. So without further delay, I would like to introduce you to Justin.
Thank you, Cam, for that great introduction. I want to start by taking a moment to thank everyone for taking time out of your busy schedule to join us today. Before we begin, I'd like to share a little bit about myself. My name is Justin Murray. As Cam has already said, I'm the operations manager of our metal business unit at Zook. I have spent almost 9 years in the rupture disc industry, working in various product development and application-specific roles. Over that time, I've had the opportunity to understand and provide solutions to many rupture disc challenges in the industry. While I can tell you that the simple device may look straightforward, its uses and operation can quickly become significantly more complex than what initially meets the eye. My hope today is to spend some time with you to share some of my personal experiences with rupture discs, welded solutions, to help you understand if and where they may be a good fit for your application. In this webinar, we will be covering some rupture disc basics, common rupture disc terminology, and sharing some application-specific information to help connect the dots between welded solution products and how they can be tailored to your specific needs. The first consideration when looking to a welded solution is to understand if a rupture disc is the correct device for your application. In order to confirm if in fact this is the correct device, you'll first need to have some basic background regarding rupture disc theory, potential challenges, and the methodology used to install a rupture disc in a piping system. We must first start with the basics of how a rupture disc works. Let's take a look at some rupture disc fundamentals. So what is a rupture disc? Let's start from the ground up. At its simplest form, a rupture disc is a safety device. To be more specific, it's a pressure relief safety device. As many of you will be aware, overpressure protection is critical in industry to protect plants, personnel, and equipment from unplanned or unexpected overpressure events. In many applications, they're required as part of general system safety. Rupture discs are an engineered weak point in a system which prevent things from blowing up in an uncontrolled manner. Unless, of course, you're looking to release pressure instantaneously. More on that later in the discussion. Anytime that we have a system capable of generating enclosed or internal pressure, we have an obligation in industry to ensure that there are safety mechanisms in place to prevent an overpressure event. You may be familiar with other types of pressure relief, such as safety valves. While a rupture disc provides a similar function, there are some similarities and differences. We will cover more details on this later. One of the differences that I'll bring up now is that a rupture disc is a one-time use device. All rupture discs use a thin diaphragm piece of material engineered to specifically rupture or fail at a specified pressure and temperature. This diaphragm material is traditionally composed of various types of metallic or graphite material. For the purpose of this webinar, we will be discussing metal rupture discs specifically. The best analogy that I have to offer when thinking of what a rupture disc does is to think about a pressurized system's similarities to that of an electrical system. Everyone is familiar with a fuse or circuit breaker panel installed in their home, workplace, or car. The purpose of this fuse is to protect from an overcurrent event. We can think of a rupture disc as a fuse in a fuse panel. When a fuse is exposed to more current than it's rated to, the excess current causes the fuse to melt and the circuit breaker to become open and not allow additional energy to build up. A rupture disc reacts in very much the same way in a pressurized system, allowing the system to vent and not continue to build pressure to an unsafe level. Now that we have a basic understanding of what a rupture disc is, let's discuss what a rupture disc actually does. A rupture disc is a differential pressure device. It is installed in a system and acts as a barrier to the outside world. It's typically a specific point of weakness engineered to protect the vessel, system, infrastructure, and personnel. A rupture disc spends most of its life in this condition, on the sideline, so to speak. It does, however, react instantaneously to any differential pressure it is exposed to. When that pressure reaches the disc's specified set pressure, it then bursts and opens to allow pressure to be vented in a controlled way, downstream or directly to atmosphere. The easiest way for all of you to understand this is to show you a burst demo video.
Here, you can see a rupture disc mounted to the end of a chamber, which is sealed at one end, and a rupture disc mounted on the other. Pressure is introduced into the chamber and the disc bursts or opens when the pressure differential reaches the set point of the disc. Differential pressure simply means the pressure on one side of the disc is higher or lower than the other. If you pressurized both sides of the disc equally, nothing would actually happen. Here's another example using water. Rupture discs are custom-designed safety devices. They can be engineered to function in both gas or liquid service, what we call compressible or incompressible service.
As in many cases, design standards govern design and commissioning of various systems. As a rupture disc can be considered an essential safety device, they're typically designed, engineered, and manufactured in compliance with several national and international standards to ensure consistency of product and manufacturing process throughout the industry. So a question I had asked earlier, why use a rupture disc over a pressure relief valve? First off, a rupture disc is comparatively speaking inexpensive when compared to a relief valve. This is especially true when exotic materials of construction are required, such as tantalum, hastelloy, Manel, and various other materials. In certain applications, leakage, even at the molecular level, can be a challenge to overcome and may not be tolerated. A rupture disc can provide a hermetic seal that is not subject to wear and tear, which can negatively affect a pressure relief valve over time. As a rupture disc is a simple passive device with no moving parts, maintenance can be kept to a minimum. Additionally, Rupture discs, in some instances, are utilized in unison with a pressure relief valve. A rupture disc is a good solution to isolate a relief valve. They are a cheaper option than the valve and are commonly used to protect the valve from direct process exposure, prolonging the valve's life, and providing a redundant seal within the system. In this case, the rupture disc would be installed immediately upstream or in front of the pressure relief valve. A rupture disc is typically installed within a system using compression. This compression usually comes in the form of pipe flanges, a threaded connection, or a sanitary ferrule. To ensure the performance characteristics of the rupture disc and that rupture occurs at its intended point, we traditionally offer a number of rupture disc holders to install the rupture disc reliably and easily into the piping system. While the vast majority of rupture discs are installed in this method, improvements to performance can furthermore be made with a welded solution. So what is a welded solution? A welded solution is really a methodology of installing a rupture disc within an application or system that utilizes various welding processes to weld the disc between one or two machined components. The design and welding method of joining the components is dependent on the specific application. We had mentioned that traditionally, most rupture discs are installed using compression of some type, usually generated by a clamp, companion flange, or other threaded methods. Welding is simply another tool in our toolbox to ensure that we can provide solutions to both unconventional installations and installations where stringent performance parameters are required. We must note that a welded solution is a custom engineered product tailored to specifically meet the needs of the application. Your rupture disc engineering team can integrate many combinations of rupture discs with housing geometry to ensure that they can meet the performance and size characteristics of an application. Once again, this welding process is easiest to show rather than explain. So I will show you now a short video of a welding process and explain the differences between this and the references made earlier to the traditional installation methods. I'll now show you a short video of the welding process. So now let's cover some of the benefits of a welded solution. There are many reasons to use a welded solution in place of traditional rupture disc design. We'll review some of the benefits of using a welded rupture disc solution over a traditional rupture disc installation. The first benefit is leak tightness. I know that I had already mentioned leak tightness as one of the values of using a rupture disc, but the welded products team really takes this to the next level. Traditionally, when we talk about leak tightness, we think about a bubble leak. Welded products go far beyond this bubble leak tightness, as the welding process has the ability to melt both the rupture disc and the housing components together to provide the most robust hermetic seal available. Once again, now's a good time for another analogy. Most people, at some point in their life, have had a bike with a leaky tire. When we think about bubble leak tightness, we think about taking some soapy water and spraying it on the bicycle tire in hopes of identifying some bubbles, and in turn, the sign of a leak. When no bubbles appear, we would assume that this is bubble leak tight. In all reality, however, we know that there's still potentially a leak. When we talk about the leak tightness of welded products, we really take this to the extreme. Welded products have the ability to offer leak-tight hermetic seals that would only allow one 3mm bubble to make its way through any potential leak path over the time span of 27 years. When we're testing to these levels, we employ a helium leak detector as our tool of choice. This allows us to accurately measure and quantify leak test results in standard industry terms. Another huge benefit to welded products is our ability to tailor them to specific mass and size requirements. Whether it's a retrofit to an existing system or a new system in design, We have the ability to custom tailor both mass and size to fit nearly any envelope that is available. The only true constraints are those that ensure the rupture disc will function correctly and repeatedly in a specific application. The third benefit is we have superior control over the design of housing components. We also have the ability to tailor fitting specific to any application. For nearly 100 years now, rupture discs have been used primarily as a source of overpressure protection in industry. I've already shared some of the benefits of choosing to use a rupture disc in a pressure relief setting, and specifically a welded rupture disc solution. Conventionally, rupture discs have been used to protect systems in industries such as oil and gas refining and processing, food and beverage, chemical processing, transportation, and life sciences. There are, however, some other value adds to a rupture disc that I haven't mentioned. Rupture discs are traditionally lighter and faster acting than a relief valve. In truth, the rupture disc is not only fast acting, but it instantaneously allows full flow, all the way up to its specified relieving area. This ability opens the door to some other uses beyond overpressure protection. Recently, many industries are taking advantage of the performance characteristics and low cost of a rupture disc solution to be used as what the industry commonly refers to as an activation device. When thinking about rupture discs used as an activation device, we have the ability to ensure that the process media contained in any form can be pressurized continually with the intent to intentionally burst the rupture disc and allow the process to flow downstream at a specifically engineered point. Pressure activation devices have been used in the market for some time now and are specifically useful in various downhole oil field applications. In addition to oil field, the automotive industry utilizes rupture discs in airbag systems, fire suppression, and battery pack protection as a few examples. Now that you have a basic understanding of rupture discs and welded solutions, it's a good time to take a look at a few case studies to understand how this technology is applied in industry to better serve applications. The first case study that I would like to discuss utilizes a welded solution in a sanitary ferrule configuration. For some background on the application, a customer was experiencing a challenge in their existing installation. The installation was challenged with leakage downstream. This challenge can arrive at times when a conventional rupture disc is used in series with a valve. You may or may not be familiar with the fact that it is common for various code bodies to require intermittent inspection of a relief valve. The rupture disc solution needed to function properly in a sanitary environment, but required a very stringent helium leak rate on both the process and atmospheric sides of the disc. By replacing the traditional rupture disc with a welded solution immediately upstream of the valve, the client now has the ability to test the valve by pressurizing the area between the rupture disc and the valve, allowing for the functionality of the valve to be validated while not interfering with the rest of the system. This solution was designed to fit into the installation with no changes required to piping and was able to be integrated in minutes. While traditional rupture discs are available in the market, the downstream leak tightness is something unique among some designs of the welded solutions product family. The second case study that we'll look at today has a very different use case. In this transportation application, mass was of particular concern. The client was looking for the lightest possible solution while still gaining all of the benefits of a precision scored reverse acting disc. They were also concerned about leak tightness at an extremely low leak rate. With all of these variables in mind, engineers were able to design a solution to meet all of the rupture disc performance and mass requirements in a welded solution. The solution was then integrated into a system successfully. In the final case study that we'll look at today, a welded solution was utilized as an activation device in an oil field downhole project. The customer had specific requirements and required a simple and small passive device to react very quickly to internal pressure. Once again, size was of particular concern here, and unique design was the only item which would fit the bill. This unit was developed from initial concept through to fit for function validation in a field-like setting. The combination of size and scored forward-acting disc performance would not be possible without deploying it in a welded solution. Rupture discs are also commonly used in plastic and polymer extrusion processes. Due to their size, price, and fast-acting nature, a rupture disc is a fantastic tool to ensure that an extruder is protected in case of a blockage or other overpressure event. The reason that this is particularly noteworthy is due to the ability of a welded product to allow the rupture disc to be positioned immediately at the process media. This ensures that the rupture disc is in intimate contact with the process. This is important as it eliminates the risk of process media buildup, which may impede the performance of a rupture disc or cause it not to burst at all. The ability to do this is something that is only possible in a welded product. Up until now, we've looked at many custom designs regarding welded solutions. The word custom can often infer expensive. There are, however, ways to gain some of the benefits of a welded solution, which can provide many benefits such as leak tightness without much of the incurred cost. A welded cartridge is designed to be installed directly into a piping system between existing companion flanges. It allows for improved leak tightness in both the positive and negative pressure directions. As industry initiatives trend towards less process waste, many of our customers are looking for ways to eliminate leaks within their systems due to cost savings or safety concerns. Now that you have a few examples of rupture disc solutions provided to the market, you will see that each one is truly a custom engineered product. The goal is to provide a product that is tailored to customers' needs and meets industry-specific standards and any other performance characteristics required. Because of the level of understanding that is required by both your rupture disc engineering team and product engineers, designers, and technicians in the field, collaboration is a key part of making any custom design successful. Through a series of questionnaires, email communication, technical documents, phone or video calls, it's important for the rupture disc engineers to have a clear, detailed understanding of the application. As with all unique products, quality control is always of concern. In the next slides, we'll cover some aspects of quality control around rupture discs and welded solutions. Quality control is a critical component of the design and manufacture of rupture discs, holders, and welded solutions. Through stringent manufacturing standards and practices, your rupture disc manufacturer will ensure the performance of every single device shipped to your facility. In addition to the standard quality requirements, welded solutions may also demand additional testing to ensure expected performance. One of the challenges that must be overcome is performing validation of burst pressure and product performance on a single-use device. In order to ensure that product performance meets all customer requirements, a variety of both destructive and non-destructive techniques are utilized. We will cover this in two parts: destructive and non-destructive testing. All rupture discs, whether welded or not, undergo functional testing. Rupture discs are manufactured in a batch, and a number of random samples from that batch are selected to be burst intentionally to verify that each batch of the product performs as intended. While traditionally, the quantity standards of discs to be burst are set out by the major code requirements, being ASME and PED, additional burst testing data can be collected at customer request to even further confirm performance. As in many cases, a welded unit or cartridge becomes an integral part of the piping system both before as well as after the rupture disc is actuated. It's important to perform housing tensile testing in order to validate calculations made at the time of design regarding the ultimate strength of the component. After first burst testing the rupture disc contained within the housing and collecting data, the device should then be hydraulically pressurized beyond what it will see in the application to validate its ultimate strength. This is intended to ensure that theoretical calculations align with actual performance in the field. Every weld design that is applied to an inline component should undergo this stringent testing requirement. In addition to a housing tensile test, macro etches may be desirable. The simplest way to explain this test is that a component is sectioned along its center line perpendicular to the weld. The component is then polished at the weld and an etchant is applied, allowing inspectors to visually see and measure the geometry of the molten weld puddle. This test is used again to further validate that calculated assumptions in the design phase remain true when applied in a practical sense. While it is important to perform destructive testing on a shippable lot, there are various tests available to validate both weld parameters and product performance, which some or an entire lot of product may be subject to upon customer request. So let's look a little bit deeper at some of the non-destructive test methods that are commonplace in this product family. Many of the manufacturing and design codes surrounding rupture discs require pressure boundary components to undergo a proof test or a shell test prior to implementation in service or as part of supplying a code-compliant product. As many welded products become an integral part of the piping system, it is critical when mandated by code, by a customer, or engineering authority to perform such testing on welded joints. Earlier, I had mentioned that leak testing is one of the major value adds when it comes to a welded product. With the use of in-house leak testing equipment, rupture disc engineers have the ability to validate not only some, but all of the components, and if required, provide exact leak rates for each unit supplied within a batch. When leak tightness is critical, this is a must-have requirement. In addition to ensuring the mechanical and leak tightness properties of a welded product, there is also a usual need for various weld inspections required by codes. If you are familiar with weld design, you will be aware of some of these processes, including liquid penetrant inspection, magnetic particle inspection, and visual inspection to ensure that the surface and visible finishes of welded joints are free from defects. X-ray and CT imaging may also be offered if your application requires validation below the surface of the material to further prove the quality of the welded joint. One of the more common questions that we're asked is, how often should I change out a rupture disc, or how long will this disc last in service? This is a real challenge in the rupture disc industry, as cycle life is dependent on unique operating conditions. In order to help serve our customers' needs, we have the ability in-house to perform repetitive cycling on designs to provide real-life values. So up next, we're going to show you some of the common terms used within the industry. It's important to note that rupture discs have unique terms required to specify product characteristics. Terms such as operating ratio, set pressure, MAWP, or maximum allowable working pressure, are all important factors in recommending the correct rupture disc solution for the application. It's important to remember that a rupture disc is a safety device that is designed to burst. Some people say designed to fail, but we like to say designed to burst or activate at an exact point. But like any engineered mechanical device, things can happen to affect performance, and this is when disc manufacturers have to use some detective work. First and foremost, rupture discs will not last forever. They are tension or compression loaded devices exposed to various forces, temperatures, etc. And therefore they will fatigue, sometimes bursting low is simply a case of service life. Another cause of fatigue can be operating ratio. It's important to understand marked burst pressure versus specified and manufacturing design range to ultimately know what pressure level of disc you will receive, and to ensure that the rupture disc you have is properly spec'd for your installation. Discs installed in systems that will be exposed to vacuum or back pressure put added strain on the device. This push-pull effect can lead to a reduced service life. It's important to let your rupture disc sales engineer know full operating conditions so that your manufacturer can supply the best product solution. Various disc designs or options will perform better in this condition. Rupture discs are an excellent solution for pressure relief, but why do they fatigue? The reason is that they are a solid state device with no moving parts. As such, by design, they have no built-in safety margin. This is, at the same time, both a blessing and a curse, as the lack of safety margin is what ensures a rupture disc will always activate correctly. But it's also what gives the disc a limited service life. Rupture discs are engineered products, but they can be delicate and fragile. Most rupture discs are what is known as reverse acting, and any minor damage to the disc dome, such as that seen in this picture, will negatively affect performance and cause the disc to burst or collapse low. Damage is a general term used to describe any negative effect on the disc itself. All disc manufacturers will take extreme care to fabricate, package, and ship you their discs, but handling in the field is just as critical. Discs should always be handled by their edges or tags, and please never touch the disc dome. Never set the disc down on its dome either. A disc showing signs of damage should not be installed. Disc damage in the field is the single largest cause of rupture disc nuisance bursts. I use the term nuisance burst loosely, and what I mean is a burst at a lower level than marked or expected. These nuisance bursts can still be expensive or result in significant loss of production or time, or both, and they need to be avoided. As I had referenced previously, coming up with a robust solution for an application using a welded product is truly a collaborative effort. You now know how to talk the talk, which engineers and experts will use when discussing your application. The initial consultation and dialogue is only part of what welded product engineers bring to the table. It's important to understand what the life cycle looks like of a welded product application. Initially, once you've reached out to a manufacturer, we will complete a high-level review. At this point in the process, it's fairly common for sales engineers to answer your questions with more questions. Please don't get discouraged by this. It's just their way of ensuring that you will receive a robust solution for your needs. Some of the topics that need to be addressed when developing a custom solution include ensuring that a solution is properly sized to allow the rupture disc to vent an adequate amount of pressure or process media, and ensuring that a good understanding of inlet and outlet configurations exists, as well as build envelope allowances. Once the physical size limitations are confirmed, we move on to additional application information, such as the operating requirements of the rupture disc itself. Here, information will be gathered, including operating pressure, back pressure, temperature, size, flow characteristics, leak rate requirements, and mass requirements, as well as any supplemental value-added process information, such as destructive or non-destructive testing, as we covered earlier. That's a lot of information. And once all of that information is collected, engineers will take all of it and work towards a design which meets your rupture disc performance goals, as well as your size and mass goals. The traditional process is then to present a design to ensure that all of your technical application requirements are met, followed by a quote. Once a solution is developed and an order received, engineers handwalk your solution through manufacturing processes and manage it cradle to grave, so to speak, to ensure that the product performs as intended. In addition to ensuring that the product is designed, manufactured, tested, and shipped within the parameters agreed. Manufacturers also provide post-sale support to answer any questions you may have that come up in the future. We are near the end of the webinar. I want to now show you the Zook video on the advantages of welded solutions. What a video. As a brief summary, welded solutions are an option available to market which can be designed to suit the needs of demanding applications. They can be custom engineered to suit a wide variety of installations and use cases. With ability to customize size, fitting, and rupture disc designs, along with the ability to offer superior leak tightness and undergo advanced quality scrutiny, this makes them ideal solution for your needs.
Thank you, Justin. That was a great presentation on welded solutions. We now have time to answer some questions that were asked during the webinar. Again, if we not get to your question by the end of our allotted time, we will make sure to follow up with you after the webinar. And the first question is, can the machine component of a welded solution have a new rupture disc installed?
Thanks, Cam. This is a good question. I think it's really dependent on the design of the housing itself. So there are cases where customers are looking to reduce cost by reinstalling a welded rupture disc onto an existing housing. This comes with some challenges though. So things like heat affected zone will pose a negative impact on material characteristics, potentially both mechanical and chemically. So that means that the material may not be strong enough, or it may not have the same inertness to various processes as it had prior to the first disc being welded on. There is an opportunity here though. In a production environment, an automated process might actually allow for a new unit to be manufactured faster and potentially even for a lesser cost than manually reworking one of these components. The answer to this question is each application is specific. So there is potential, but we would have to review. Is there another question?
Yeah, that was great, Justin. Thank you. The next question is, can Zook help with developing a part for a new or special application?
This is a good question as well. So in the presentation, we touched on several times that Zook has the ability to offer turnkey services in-house, services such as custom product engineering, application support, manufacturing engineering and support, as well as post-sales support, allows us to develop a new product from concept all the way through to post-sales support. This is something that Zook absolutely can do. Are there any other questions?
Yes, thanks, Justin. Unfortunately, we only have time for one more question. And the question is, can exotic materials be used?
This is a tough question. So there's a couple of factors that we have to consider when looking at what rupture disc materials can be used. So we have first the rupture disc material itself and the housing material. So fabricating metal rupture discs requires a large library of material, not only types of material, but large varieties of each material. Because of that, we typically can only offer solutions with materials that are part of our material library. Now that's the rupture disc side. When we look at a machined component, we can offer many unique materials. At some point in time, we have to integrate dissimilar materials potentially in terms of a rupture disc and a welded machined component. So that really becomes contingent on the laws of chemistry. We can't overrule the laws of chemistry. Materials must be chemically compatible and weldable to be considered for a welded solution, regardless of the welding technology used.
Okay, thank you, Justin. We're now approaching the end of our allotted time for this webinar. I would like to thank Justin for his expertise on welded rupture discs, and would like to thank everyone that attended today's webinar. The webinar will be archived for future viewing on our website at zookdisc.com, and everyone that registered for the webinar will also be sent the video in the next 48 hours. Thank you again, and have a good day.